let's solve the quiz problem. So we have a charge Q located at 1, 1, 0. Find the electric field vector at any point on the z-axis. So we are writing it in vector component form. So f of z, g of z, h of z represent the functions for x, y, and z components. Find them. And then once we obtain the electric field vector as a function of z, we will verify its magnitude and direction at the origin and for z much greater than 1, very far away from the charge. Okay, so x, y, z. So if this is x equals 1, this is y equals 1. So our charge is located right here. So the location is 1, 1, 0. Okay, so our source point is r prime x hat, 1 times x hat, 1 times y hat, and there is no z hat. The field point is on the z-axis, right? So right here, say field point R, and that's 0, 0, z, right? So it's only z, z hat. Okay, so we are going to find the electric field vector. I mean, based on Coulomb's law, we can just write E is 1 over 4 pi epsilon naught Q over script R squared script R hat. Since we know script R hat is script R vector divided by script R magnitude, we can also write this as 1 over 4 pi epsilon naught Q script R over R cubed. So based on the field position and source position, I can find script R equals to R minus R prime. So in this case, my script R for this point charge would be z hat minus x hat minus y hat. Okay, so its magnitude, so this is my script R that I will use here, and its magnitude would be script R square root of z squared plus 1 squared plus 1 squared. So its magnitude is z squared plus 2. Okay, and that's going to be used here. Okay, so once I put that in, I have the electric field. It's going to be 1 over 4 pi epsilon naught Q over 4 pi epsilon naught z hat minus x hat minus y hat divided by r cubed. So I'm going to take the cube of this, which is z squared plus 2 3/2. Right? That's my electric field function. So based on this, I can write f of c, g of c, and h of z. Right? F of z is the x component, so it's going to be minus 1 over 4 pi epsilon naught q over z squared plus 2 3/2. Similarly, g of z is minus 1 over 4 pi epsilon naught q over z squared plus 2 3/2. H of z is the z component, so it's going to be 1 over 4 pi epsilon naught q times z over z squared plus 2 3/2. So these are the functions. You know, that does most of the part of the problem. Now we need to do verifications. Now at the origin, well, if we're at the origin, right, at the origin, the electric field vector will just point away from the charge. It will be purely on the x, y direction. So if these functions are correct, at the origin, h of z must be equal to 0. And you know, the z will be 0 at the origin. So the distance here is just, this is 1 root 2, right? So then square of that is 2. So it should be a very simple function for f of z and h of z. So let's see if that's correct. So, and lo and behold, that's correct because h of 0 is indeed 0. And f of 0 at the origin, right, is minus 1 over 4 pi epsilon naught q over 2 to the 3 halves, right? This is going to be 0, 2 to the 3 halves. So square root 2 cubed, right? And that's expected because square root 2 squared is going to come from the Coulomb's law, but there is this 45-degree angle. And if I want to multiply this by cosine 45, that's what I'm going to get. That's why we have 1 over root 2. Another root 2 comes from that. That same thing applies for g of 0, right? That's going to be minus 1 over 4 pi epsilon naught q over, again, 2 to the 3 halves. So all of them work out at the origin. When z is much greater than 1, now I'm very, very far away. So this is, I'm very far away. So this is going to appear like a charge at the origin. So I mean, the x and y components should go to 0. And z component, again, needs to be expressed as simply 1 over 4 pi epsilon naught q over z squared. So let's see if that happens. Z much greater than 1. Then if I look at f of z, then as z goes to a very large number, f of z indeed goes to 0, right? Because I have z squared here. It's divided by z squared. Same thing for g of z. So no x and y components for z much greater than 1. How about h of z? Well, in that case, I need to do a little bit more work for h of z. Here I have z squared much greater than 2. So this, z squared plus 2 is about z squared for z much greater than 1. So in that case, I can just write z squared plus 2 3 halves approximated to be z squared to the 3 halves, which is z cubed, right? So if it is z cubed, then I can write h of z 1 over 4 pi epsilon naught qz over z cubed. So these cancel. So indeed, it becomes 1 over 4 pi epsilon naught q over z squared, right? Only the z component survives, so that works out as well. I hope you enjoyed this solution.